Hey class, this is Mr. Wynn here with a video on 16.1. This is the intro to quadratic equations. So it's called Understanding Quadratic Functions. So just real quick, brief intro. We learned about linear functions last semester. This semester, we learned about exponential functions. Okay, remember those are different. So linear is a straight line, where you're adding the same thing each time. Exponential is when you're increasing by a certain percentage or decreasing by a certain percentage. So it can either be exponential growth or it could be an exponential decay, like that. Okay. A quadratic is neither linear nor exponential. It's its own kind of function. Okay, quadratic. All right, and it's gonna look something like this, or it might look something like this, and we'll get into that. Okay. So, understanding the parent quadratic function. So a function that can be represented in the form f of x equals a squared plus bx plus c is called a quadratic function. Okay, this is your form. Okay, without the is. There we go. So all it is notice that this is just a polynomial. Okay, last unit we learned about polynomials. Try to figure out how many terms we have here. We've got the ax squared, the bx, and the c, so we've got 3 terms, so this is a trinomial. Now try to figure out what kind of degree this is. What degree is the polynomial? Hopefully you should remember the degree here would be 2, because that's the exponent, the degree of the highest term. Okay. The degree of the term with the highest degree. Okay. So if it has a squared on top of your x, or your whatever your variable is, then it's a quadratic function. Okay, and a, b, and c can be any constant, except that a can't be 0, because if a was 0, then this whole term would be gone. Then you're left with just bx plus c, and that would actually be a linear function and not quadratic. Alright. Okay, the most basic quadratic function is this f of x equals x squared. We call this the parent quadratic function. Okay, it's the most basic, that's what it says, the most basic quadratic function. And so when you think of parent, think of it's kind of like the original, so to speak. So then we're going to have other quadratic functions that take this one and change it up a little bit. Okay, but we call this one the parent function, kind of like the original. So real quick, let's get used to that parent function, what it looks like. We could fill out this table of values, so -3, -2, -1, 0, 1, 2, 3. And for my y values, all I'm doing to get my y value is I'm just doing x squared. So if my x is -3, I'm going to square that, and here they got 9. Okay, -2 squared is 4. -1 squared is going to give you 1. If you put that into a calculator, just make sure to put the negative inside of parentheses. Sorry, I meant to highlight that. Make sure to put the negative inside of parentheses, or else the calculator won't take it correctly. Okay, 0 squared is 0, 1 squared is 1, 2 squared, it's going to be 4, 3 squared, it's going to be 9. So let's plot those points. I got -3, 9, right here. I got -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Alright, I'm trying to go fast because YouTube limits me to 15 minutes per video. So I may break it up into 2 parts, but if I can't, just pause and rewind anytime you need to catch up on anything. Okay, so here's all my points. Now I'm going to draw in my curve. Okay, it's going to go something like this. Alright, one thing about this kind of curve, okay, this is not really great, but one thing about this curve is that you don't want to make it pointy at the bottom here. So another way you can draw it is just do it 1/2 at a time. Okay. Yeah, you don't want to make it pointy here, because if you do, it's going to look like a different kind of function, which you'll learn in Algebra 2. But it should be kind of a curve, like a valley, like that. Okay. Alright. This kind of curve is called a parabola. Alright, that's how you say it, parabola. Parabola. The point through which the parabola turns direction is called its vertex. So our vertex is right here, where it's it's going down, then it switches direction and it goes up. That point right there is called the vertex. It happens to be at 0, 0. A vertical line that passes through the vertex and divides the parabola into two symmetrical halves is called the axis of symmetry. So let me draw that in. So here's a line. It's cutting through my vertex right there. And it's splitting the parabola into two symmetrical halves. So on this side of that line, that curve right here, that part of the parabola, is exactly the same as on the other side, except that it's mirrored. Alright, we would say it's reflected across the axis of symmetry. So that line goes directly in the middle, where the two sides of the parabola are mirror images of each other. So if you were to rotate this parabola around that axis, it should have the same image. So that's a parabola. This is our parent function. Just f of x equals x squared. Okay. So domain and range. Domain, you can put any x value into this function, meaning all real numbers, or you could say negative infinity to infinity. In our range here, our lowest value is going to be 0, and then we're going to go up and up and up and up from there. So our range is going to be, it's going to be y, oops, yeah, that's the bell, y greater than or equal to 0 for our range. Alright, when we graph, so we graphed the parent function earlier. Now we're going to do a slightly different function, so this is not the parent function anymore. We're going to change it where our a value, our coefficient in front of the x squared, is going to be different. So we looked at the Desmos in class. I'm not going to pull it up now, but when your a value is greater than 0, we say a parabola is going to open upward. Upward looks like this, okay? But downward is going to look like that. Okay, so when it's greater than 0, parabola opens upwards. When the absolute value of a is greater than 1, our graph is going to get narrower than the parent function. So here's the new function. So f of x is the parent function, the g of x is the new one. It's getting more narrow. We actually call this a vertical stretch, because really I'm taking these ends and I'm like pulling them up so that it's like a rubber band and it's stretching. So now it's like, really it would be like that, but it would go off the page. Okay. So we call this a vertical stretch when a is greater than 1. When a is between 0 and 1, it's going to flatten out like this. And we call this a vertical compression, because it's kind of like if I take this parabola and I pull it down, push it down, then it's going to compress into that one. So vertical stretch, vertical compression, you got to know those terms. Alright, lastly, when the graph it opens upwards, then we're going to have a minimum value. Sorry, that's the vertex actually. That's the lowest value on the parabola. So it goes down, that's its lowest point, and then it's only going to go up from there. Same thing, no matter which way it's stretching or compressing, as long as it opens upwards, our a is greater than 0, then it's going to have a minimum value. Alright, so you can look through these examples. These are just graphing different kind of functions. So example, with 2x squared, they just take this x and they plug it into this equation, 2 times -3 all squared. Make sure you use parentheses if you were to do that in your calculator, but they just got all those values in here. They graphed a function. You can go ahead and graph this one as well. That would be good practice. Just take your x values, plug it in for your x. So just to make sure, if you put it into a calculator, you would have to put it like this. So your -3 would have to be inside these parentheses. Okay, if you don't do that, then it's going to take it wrong. Alright, and you can graph that. Fill out the table and graph that. Alright, Okay, now when a is less than 0, we say it opens downwards. Again, that's when it looks like this. That's what it would look like if you're throwing a basketball in the air or something like that. Okay, when a is less than 0, it's going to have a maximum value because you go up, and then at a certain point you're at the max value, and then you're going to go down from there. So this is going to have a maximum value. Again, we can vertically stretch and vertically compress. When our absolute value of a is greater than 1, we're going to vertically stretch. So it's going to look like this. And when the absolute value of a is between 0 and 1, we're going to vertically compress. That. Remember, absolute value means the positive version of a. So if my function is negative 4x squared, my a value is negative 4, the absolute value of a is going to be 4, and that would fall under vertical stretch. Okay, but if my a value is like negative 1/2, then the absolute value of that is going to be 1/2, then it's going to be a vertical compression. Okay. But again, when a is less than 0, that means a is a negative number. When it's a negative number, your parabola is going to open downward. When you have a positive a, your graph is going to open upward. Let me write that. This is a is negative, a is positive. Okay, so you can graph these again. Just use your equation. Now, last topic, I believe. So what we did was we had a quadratic function, and then we created the graph. Now we're going to do the opposite. We're going to look at a graph, and then we're going to write the function from it. So, first things first, if your parabola has your vertex at the origin, remember the vertex is the point where it changes direction, either your minimum or your maximum value. That's my vertex there. If your vertex is at the origin, then your parabola is going to be of this form, a times x squared. All right. So, a times x squared. If we have another point on the parabola, what we can do is plug in. Here my x value is 2, my y value is also 2. Let me change colors here. Okay, that's xy. So here they plugged in 2 for x, and they also plugged in 2 for y. G of x is the same thing as y, it's just your output. We plug in those x value, that x value and that y value into this general form because we want our equation to look like this. We don't have a yet, so we need to solve for a. Okay, we plugged in everything else. Now we can solve for a. 2 squared is 4, so they got that. Divided both sides by 2. Sorry about that. Nope. They divided both sides by 4. And they got a is equal to 1/2, so they just plug that right in for their a up here. So g of x equals 1/2 times x squared. Let's do an example together here. First things first, double check that where your vertex is. My vertex is at the origin, so I can use this method. I'm going to have g of x equals a times x squared. Now I'm going to plug in a point. Let me use this point, -2 and -8. -2 and -8. So my x value is -2. I'll put it there. My y value is -8. I'll put it here. I want to solve for a. So I'm just going to solve this equation. So -2 squared is going to be 4. So 4 times a. I want to get rid of that 4. I'm going to divide both sides by 4. Get -2 right there. Divide both sides by 4. So a is -2. And our form is ax squared. So my a is -2 times x squared. And that's all there is to it. So step 1. Write your form like that. If you know the vertex is at the origin, you have ax squared. Step 2, plug in your point for your x and your y. Solve until you get your answer for a, then plug it into your equation that you had originally. Alright, that's it.